Hello there. Today I want to do a quick little overview video of a Siglent SHS806 handheld portable oscilloscope that I picked up recently. Now, this is a pretty cool device. It is a dual channel 60 megahertz oscilloscope with built-in modern software features. Well, I say modern. This thing is from, I think, 2013, but the newest oscilloscope I have compared to this is probably from the 90s. So to me, this all feels crazy modern. Now, this thing is a dual channel 60 megahertz oscilloscope, although this product range goes from 60 all the way up to 200 megahertz. It also has a built-in multimeter. Don't expect to like it, and a bunch of modern software conveniences, as well as a USB client and host port. This thing is pretty cool. Alright, now my example of this device came in this handy carry case, because despite this thing being portable and handheld, it's really not very small at all. It's extremely large, actually, but it probably shouldn't be much smaller than this. Now, I'll say that the video might look a little weird here because I've had to really highly expose this shot and make the lights in here extremely bright, because there is no way to adjust the brightness of the display, so it's always running at maximum brightness, and it's really hard to film with well, other lights that just maybe aren't as bright. Now, it is possible to go into the scope settings and set the display to an inverted view. That kind of makes the colors a little weird, but this is probably how I will run this for the rest of this, because it helps somewhat, but it's still really bright, as you can tell in these areas. Don't mind the ceiling fan that I just shut off so we don't get strobed here. Now, you might wonder why get a portable oscilloscope like this, and the main reason is having total ground isolation. Because your probes are floating relative to ground, because this is battery operated, you don't have to worry as much when you are probing power supplies, because you will never accidentally short the wrong ground to main ground. Now, if you've seen Dave Jones's video of how not to blow up your oscilloscope, that is about how you can damage a mains powered oscilloscope by connecting your probes to the wrong thing. With this, there is no wrong thing to connect this to, because your single probe measurements are effectively always a differential measurement, which is extremely handy. I've already used this to diagnose a Deck Rider 3 that was having power supply issues, where a positive and negative supply rail had bad capacitors that were having 4 volts of ripple on the power supply. We'll get to that project in a future main channel video, but I was able to use this oscilloscope to measure that power rail without having to worry about whether or not that middle positive negative ground leg was actually tied to the mains ground. And also, in general, just having a portable oscilloscope is really handy. When I was working on the Deck Rider 2, I'd stacked up a bunch of random test equipment next to it so that I could get probes near the thing so that I could actually measure it, because that device was too big to put up onto my desk. So having something that is, you know, not small, but at least reasonably portable, still pretty handy. All right, let's go over some of the features that this has, and I'm going to use some synthetic signals here to demonstrate this. So the first thing I'm going to run into this is just some sine waves coming from my computer so that we can see stuff. Now, I'll call out here that these are, I don't know what this would be, insulated BNC jacks. They're kind of strange because the outside of them is not conductive, and I don't know why. Probably some safety nonsense, but it means that some of my BNC cables don't really work well with it. Now, I'll call out here, before we move on too much, that this is actually I'm not going to be able to pronounce this French word, Lugis square, something like that, figure. And this can't display it. And this can't display oscilloscope music either, even though we are in XY mode, because this is a sequential sampling device. I think I did get it to display this pattern before, but I was using a signal generator instead of a computer to display this, but it definitely does not display oscilloscope music. So just keep that in mind. Not that you would buy this just to play oscilloscope music on, but there are some limitations because of the sequential sampling. Now, what I'm going to do is I'm just going to hit the auto button because it'll figure out how to display a couple of sine waves easily enough, and bam, there we are. So we are getting here some measurements on the voltage for the peak to peak. We got the total peak to peak voltage right there. Over here, if we could read that, I'm going to re-invert the display. We can see it is a 1 kilohertz signal. Channel 2 is actually slightly different just because I was trying to get the figure to work. But anyway, so yeah, it was able to lock onto that pretty easily. Now, there are some cool things that we can do in this. All right, there we are. It seems that my cable doesn't fit extremely well, and I do have some issues with these BNC jacks because of that insulated outside. So I'm assuming this signal bouncing is problems related to my cabling. Although I will say, when I first got this thing, I cracked it open because the handle fell off, and I discovered one of the ground connections, specifically for the channel 1 here, had broken internally, and I had to resolder that. So, you know, these are not necessarily extremely well built, although I don't know what the history was with this thing before I bought it, because I did not buy it new. All right, now on this, we can do some cool stuff with math. So here is an FFT. Now this is 12.5 kilohertz per division on here, and these are 1000 hertz sine waves, so it is up at the bottom right there. So if I pause the signal, it kind of stops. But yeah, this is not great. You can't get this down to just audio range, which would only be these first 2 divisions. If you try to zoom anymore, FFT zoom at limit. So that's kind of unfortunate for audio diagnostics, but it's not really what it's meant for, although it is really good at video, which we'll see in a little bit. Now, you can do some other cool things with these kinds of measurements. So if we go back to this, we could do something like, you know, a plus, a minus, if we're doing differential stuff, all those kinds of things. But we can also do a different kind of measurement. I'm going to go ahead and turn the measurement channel off, and then we can do a cursor measurement. Now, there are different things that we can do with these kinds of measurements. Where is what I am looking for? Here we go. So we have these different measurement options that we can put on here. So if we pick channel 1 right there, we can pick different things that we want to measure. We can measure like 30 some different things on here. And what's cool is we can go to recorder, and then we can go to trend plot scope, and we can actually chart those measurements. So here we are charting the channel 1 voltage peak to peak, and then here we are charting the channel 2 frequency over time, so that we don't have to chart just the oscilloscope waveform itself. We can actually chart the resulting information that we can measure from the oscilloscope waveform. I assume this is my cable doing weird stuff, but this is a really cool, handy feature to have. Now, something else you can do with this is if I grab a flash drive here, I can plug this into the side of this device. It will recognize USB flash drive plugged in. We can go to, is it menu? No, where is it? Save recall, type picture, save, and we can just straight up take a screenshot of the display and save this to our flash drive. Now, we can also save data sets and some configuration information. It's kind of crazy what all you can save. I have not fully explored this, but it is really powerful, which is super cool because I will be able to trigger on something and then get the waveform to display on here. Let's go ahead and return. So let's say I do a one-shot trigger like this. I can then take a picture of this. I think acquire somewhere in the scope settings, we can just directly save to this. But yeah, anyway, this works out really handy for my purposes of video stuff. Now, you know, this isn't that impressive for a modern oscilloscope, but to be able to do this on a handheld one, I really like. You can also connect a printer directly to this and just print the screenshot directly to paper, which is kind of weird and cool, and I assume goes with the portable service tech kind of use case that you would have for this thing. But that's not what I'm using it for, but still kind of weird. All right, now let me talk about something that is less cool with this. The meter. All right, so this has a built-in multimeter, and I initially thought, oh, this is awesome. I'm going to use this meter all the time, not because I think this is a good meter, because I want to make this my one-stop shop piece of bench gear for just working on random things, because it uses a rechargeable internal battery. The battery is actually right there. You can get replacements. And if I just use this as an oscilloscope, I am likely to forget to charge it before I need it, and then it won't be ready when I have a use case. So I was hoping I could use it for, multimeter stuff, and then it would always be ready, but turns out the multimeter side of it is not amazing. That was super slow. So here we go down to 0 volts, and then this is a dead 9 volt. It's at 6 volts, and so I used this thing to diagnose a car battery the other day, and it was actually a little concerning because it seemed like the car battery was dead, but it was actually this thing being so slow. So yeah, it doesn't really matter how good of the meter this has on it. It's so ridiculously slow. And I don't think you can change the sample rate or the precision or anything to make it better. It's just like that. Now you can trend the multimeter reading too, which is just, a really slow oscilloscope in a way. But I don't know. I will probably have times where I use this, but this is definitely not as useful as I was hoping it would be. All right, so those are the main features. There is one other cool thing about this, but I need to set some stuff up first. Behind me, you can see that I have STMPE color bars being displayed on my TV. Well, I also have this signal running off and over to the Siglent handheld oscilloscope. So let's see what we can see with that on there, because this has what I think is a super cool feature. And over here, we are, in a sense, capturing that STMP color bar signal on here, but we're not just triggering on the horizontal sync pulse. We're actually using a video trigger mode that allows us to step through different line numbers. I have my standard set to NTSC, which is going to dictate how many video lines there are. But if I get rid of this, I can walk through the different lines of video that the source over there is sending, so we can see the transition from the color bars to the alternating bars here. The trigger source is not super clean on this, so it's flickering back and forth. I tested this with an actual NTSC pattern generator before, and it looked a lot better. So your mileage may vary on how well it triggers. I've tried adjusting the trigger level, and I swear before I actually had the best time just setting it to auto. I don't know what magic it was doing with that, but this is really cool. So this is good for being able to verify different video things. Like in this case, I can zoom in here to make sure that my S-video cable is actually S-video and that we don't have a color burst in the video line there. In this case, I know because I made the S-video cable that is connected to the Super Nintendo in this case, outputting this using the 240p test suite. So yeah. Still though, this is in my opinion, super duper cool feature. I don't know why something from 2013 needs to have the ability to do NTSC signal locking like this. That it feels a little weird, but man, I really like it. Well, that is the Siglent SHS806. I'm very happy with this purchase. A little disappointed in the multimeter side. Also, I will state that I thought that you would be able to use the multimeter for an external trigger source on this. No. You can think of the multimeter as just being a completely separate device, just bolted on in there, that just overrides the control to the display from the oscilloscope. They have zero bearing on each other whatsoever. It's kind of weird. I would honestly rather see the DMM just be removed and maybe focus on more oscilloscope features, because The MM is not amazing on this, but other than that, I think it's really, really cool. Well, hopefully that is helpful. If you wanted to know more about a portable oscilloscope or this particular one, I am very happy with it outside of the multimeter stuff, and I'm glad that I picked it up. Well, that's all I've got for now, so I'll see you next time.